Hello everyone, welcome back to CSE Core Concepts in my series of machine learning algorithms with implementation in RStudio. In this video, I am going to demonstrate some simple small problem as how to use the random forest for solving the regression problems. As for the data set, I am using the same insurance data set where it is going to determine the insurance premium charges based on the parameters such as the age, gender, BMI, number of children, whether is a smoker or not, and the region and charges. We are not going to consider the region for here. We can consider, we may not consider. So let us assume that we are considering all the parameters here. So let us get started with the data. So the first thing we need to do is include in the library file and of course read our data. So let us have a look at the structure of the data. So the structure of the data is let's say whether it is categorical or not. No, we can see here the data is not categorical. Integer, children, age all has to be even at least not age is integer, fine. Gender has to be categorical because there are two levels, female and male. BMI is okay, it's numeric. Okay, the number of children we can have categorical, right? Then the smoker has to be categorical and the region has to be categorical. So let us first convert the data, some of these data into a categorical data type. We cannot convert age, but of course we can consider the gender, okay, as whether it is as to be categorical. Then let's say the number of children, how many, that can be categorized of course because you can category based on like less than one or some more than one, less than two, like that. Okay, so we can always do that. Children, then with the next parameter which we want to convert it into this factor is number whether it is smoker or not. So of course it will have only two categories, that yes, he is a smoker or he is not a smoker. Then the region, okay, so if we have just we can categorize the regions also, that which region the person belongs to, right? So let's say we are determining. So here you can see that your data output is of course your output is numerical, right? So this as where gender is converted into a factor of two levels. Children is again factor, then smoker and region. Done. So we have seen the structure of the data. Now let us split our data into two parts, right? So split the data into, of course, two samples, that is our training and testing. So my data, then replace is equals to true and probability of the training and testing, let's say 80 and 20. Okay, and let us consider here the training data. So training data will contain the first sample of the my data. So split data is equals to 1 for all the columns, and test data is equals to my data split data is equals to 2, right? So let us see here. Okay, so my test data now contains 269 observations and training data contains 1069 observations. So let's say insurance underscore the random forest classifier. Let us call the function random forest and we want to compute the charges against all the columns. Let's consider all the columns and data is our training data. And if you want to see the model, let's say insurance underscore RF, right? Let's see how it is performing. So this is what is being statistical analysis. So it is a regression type of a problem. So in my earlier video, when I was discussing random forest for classification, that was the classification problem. The number of trees which has been created is 500 trees are created at variables. Number of variables which have been tried at each split is 2. Mean of square. This is an important parameter when you are performing the regression analysis. So this is the mean of square errors. So this is what is being observed, right? Now let us do one thing. Let us create let us see. Okay, this is coming null. See, if I am trying to create a confusion matrix, it is giving me null. Why is it giving me null? Because it is a regression problem. If it is a classification problem, then they can give us the correct results. Okay, so random forest will do the predictions. Let us do the prediction how well my model is performing using my training data. Okay, and we don't wish to see all of them because it will become too much. We have so much of data there. So let's see only the head. Okay, so let's see. Okay, these are the predictions which have been done. Similarly, you can do the random forest predictions for the test data also, right? Yeah, so you can do the predictions for the test data. Your model is insurance underscore RF and test data you can pass, and of course you can see some of the results of the test data. Okay, so let's create it, do the predictions. Fine. So of course we can see a plot of it. That will be more interesting to see. Let's plot it, plot the model to understand it better. So this is what the error was initially increasing, and after, let's say here from after 200 or some trees, the error has become, it is now parallel to the x-axis. There has been no drastic reduction in the errors. Then of course you can see the histogram of the tree size, insurance underscore RF. So you can always see the histogram over here. So you can see the histogram of the number of trees and the number of variables which are being used. You may even see the important variables. So very important plot also you can see. Let's see. I want a sorted way. So let's say sort is true. So this is what the plot. So let's see which parameters are important. So most important is this one, smoker. We can see smoker affects it, age, and then comes age and BMI. Gender, region, and number of children are not majorly contributing, right? So you can see the importance of them. Right? So you can see the maximum comes for the smoker value, right? That is what we just saw in the graph. And we can also see the variable used in this model. So first variable age has been used 35,411 times. Then comes your gender. So these are the number of frequencies for which each variable has been used for the split, right? So that's all about your random forest problem algorithm for the regression analysis. Thank you for now, and please don't forget to like, share and subscribe to CSE Core Concepts. Thank you.